Welcome to CAESS ProTop version 5, and this is a short video on ProTop's very unique capability to create and optimize shell or lattice-like structures. Okay, we will start with a simple solid part, and the objective is to optimize this blue region, not as a solid part, but rather as a combined shell-lattice structure. Now, to achieve this, we simply switch to the Optimization Model tab and open the Part Configuration dialog. Within this dialog, we simply add a configurator, and let's say that the first one will be of a shell type. For the shell, we have to enter the corresponding surface to which the shell will be applied, and at least the thickness limits, let's say from 3 to 5. Okay, we should take a look what we have done. We have a nice shell-like structure, and now we would like to add some lattice in the interior. Close this. We will just add another configurator, lattice data. For a lattice configurator, we have to choose the corresponding domain and of course the lattice type. For example, let this be a honeycomb cell. We have to choose the lower and upper limits for the cell bars. For example, from 4 to 8. Okay, let us take a look what we have done. Okay, I have to emphasize we can change rather quickly here everything. For example, I just want to raise this a little bit. Okay, so we are done, and we are ready to take a look at our configuration space. We run some design analysis, and this is the currently configured design. The lower limits look something like that, and the upper limits are something like that. The optimizer is now free to do anything only within these limits. Okay, to illustrate this, I will run briefly the optimization. I will start only with initial FIA. Okay, this is the stress state of the initial design. If we pay attention to this region, we can see that the stress levels here, the maximal stress levels, are about 110 or 17 megapascals. Okay, I will now fix the stress scale and run a few optimization cycles. The material is redistributed a little bit, and as we can see, the stresses reduce essentially. Okay, this will do it. Okay, one can see that by running only a few cycles, the stress levels in the region here were reduced essentially from 110 to, let's say, approximately 60 megapascals. So this is a very substantial reduction, and this is why topology optimization in shell lattice structures is so important. Okay, before we end, I would just like to point that the mesh that we use is far too coarse for a real example. So it is nice for a demo because it is quick, but in real life examples we would need to use a much finer mesh. Okay, this is all, and thank you.